All right, so we already did these problems. You can just kind of pay attention and follow along. It says here at the top, graph the set of points that would satisfy each inequality. That means just graph the inequalities. These inequalities are hard to graph in the form that they're currently in. I prefer to graph things in slope-intercept form. To do that, you would just take the inequalities and solve them for y. The first one, I would subtract both sides by x. I get negative 2y is greater than or equal to negative x plus 6. And then to get rid of the negative 2, I would divide everything by negative 2. You just have to be really careful because when you have inequalities and you divide by a negative, the sign flips. So it's going to turn into less than or equal to. Negative 1x divided by negative 2 will become a positive 1 over 2x. And then 6 divided by negative 2 is negative 3. So the inequality that I would graph from that first example is y is less than or equal to 1/2 x minus 3. On the y-axis, I would start at negative 3 and make a point. My slope is 1/2. That means from this point, go up 1 and over 2 and make it another point. Up 1 and over 2. Then you have to decide what type of line to use. There's two types of lines in inequalities. Either solid lines, which is what we're used to using, or dashed or dotted lines, whatever you want to call it. This one would be a solid line since it's a less than or equal to, so I would just draw a line straight through those points that I just graphed. And then for every inequality, you have to determine which side to shade in your solutions. Each line will cut the graph in half, and in this case, you have the above region or the below region. The easiest thing to do is to select a point and test that point to see if it's true or not. If it's true, that area is the solution region. If it's false, the opposite area is the solution region. The easiest point to test is 0, 0. That's because whenever you put in a 0 for y or x, everything turns to 0, and you're just left with 0 on one side, and then whatever the y-intercept is on the right-hand side. So we have here 0 is less than or equal to negative 3. 0 is not less than or equal to negative 3. Because that's false, that means this entire region up top is false. If all of these points are false, that means that the solution region is down here below. The next example, we have variables on both sides, and we want to solve this for y. I usually like to see my y on the other side, but because this 5x can just be quickly moved to this side, I'm just going to subtract both sides by 5x. 3x minus 5x is negative 2x. So I get negative 2x minus 2 is less than or equal to y. I prefer to graph this the other way just because I like to have my y first. So if you're like me and you would prefer to have the y first, you're just going to flip everything around. The negative 2x minus 2 will be here, the y will be here. But when you do flip this, you would have to flip the sign as well. So here's what it would look like in almost like slope-intercept form with the y first and all the other stuff second. To graph this, you would start at negative 2 on the y-axis. That's kind of off. And from here, your slope is negative 2 or negative 2 over 1, which means you would go down 2 to the right 1. It's really off. You try again. Negative 2, and then down 2 to the right 1 would be about here. This is another solid line because of the less than or equal to. And then we would test the point again to see which region is the solution region. Since 0, 0 is not a part of the line, I can use 0, 0. When I do that and I put in 0 for y and 0 for x, I'm left with a true statement. 0 is greater than or equal to negative 2. Because of that, the entire region up top is the solution region, so you would shade up top. So that's how you graph inequalities. Step 1, solve for y. Graph your slope and y-intercept. Determine if it is going to be a solid line or a dashed line. Test the point. 0, 0 is the easiest point to test. See which region is the solution region, and then you're done. The next 3 questions are asking us to create the inequality from the graph. The graph is already there for you. We're just going to create the inequality that matches up with the graph. For these problems, like on yours, you might be able to see it better. On mine, you see double colors. The green is the shaded region for these problems. So they give us 2 points that they want us to use, and they show us the type of line, and they show us the solution region, and we want to create an inequality that represents this graph. So the first thing you should do is remember slope-intercept form for equations is y equals mx plus b. For inequalities, you would use the same thing, but instead of having an equal sign, you will either have a less than, a greater than, or less than or equal to, or greater than or equal to sign. To figure out the slope of these lines, you can either count or you can use the slope formula. If I look at the point 0, 2 and the point 4, 6, I would find the slope by doing 6 minus 2 divided by 4 minus 0. 6 minus 2 is 4. 4 minus 0 is 4. The slope of this line is 1. The y-intercept is already given in the problem. What will the y-intercept be for this first graph here?
2.
2, yes. So they give us the slope. Well, sorry, we found the slope. They have the y-intercept already there. It's 2. So the equation, if it was an equation, it would be y equals 1x plus 2. But because it's an inequality, it's either going to be y is less than or equal to, greater than, or greater than or equal to. So I'm just going to set it up by putting y and then a space, and then 1x plus 2. The next thing to do to determine what type of symbols you can cancel out or cross off is look at the type of line we have here. This is a dotted line or a dashed line. Because it's that type of line, what are the only 2 inequality symbols it could possibly be?
Less than or greater.
Yes, so it's either going to be less than or greater than because of the type of line we have here. So the best thing to do is cross off these 2 and realize it can't be less than or equal to or greater than or equal to. It has to be less than or greater than. So what I like to do then at this point is use the idea of testing a point again to see what's true. Now, most of the time, the symbol you think it would be will actually work. Like, because this part, the shaded region down here, to me, if I'm looking at this line, this shaded region looks like it's below the line, which is would me, like I would think less than. That thinking usually does work, but sometimes it doesn't. So what I would do is determine a point, use a point to test. I'm going to use 0, 0, again, since 0, 0 is a part of this statement. If I replace y with 0 and x with 0, this will end up being 0 plus 2, which is 2. And we would want a true statement. 0 is blank 2. 0 is less than 2. I would want that to be true since this area is shaded, which tells me and helps me realize that this symbol will be y is less than x plus 2. Now, if you notice, just by looking at the graph, I would think just by seeing that shading being below the line, it would make more sense to be less than, but sometimes that thinking doesn't work depending on the type of line we have. So the inequality is y is less than x plus 2. Using that same type of thinking, I want you to try the second one over here, which is very similar to the first one. 2 points are given. You need to find the slope. The y-intercept is given. You have to create the equation first, and then instead of using the equal sign, pick which symbol you would use, less than, greater than, less than or equal to, or greater than or equal to. I'll give you a few minutes. We'll go over it, and if you're ready to try that last one while you're waiting, you can try it. It's just different than the first 2. All right, so let's go over this example, and then we'll move on to the last one together. So they give us the 2 points they want us to use, 1, 2, and 0, 0. So the first thing we can do is find the slope. Using the slope formula, 0 minus 2 over 0 minus 1. 0 minus 2 is negative 2. 0 minus 1 is negative 1. The slope simplifies to just be 2, or 2 over 1. The y-intercept they give us is actually the same thing as the origin. The y-intercept crosses at 0, 0 there. So you don't have to necessarily put in a y-intercept since b is 0. So the equation would be y equals 2x plus 0, or just y equals 2x. Because this is not an equation, it's an inequality, I like to just put a space there and then determine what symbol to use. Because it's a solid line, the only options would be less than or equal to or greater than or equal to. Then I have to decide which symbol it would be depending on the shaded region here. So the shaded region is like above it to the left. So like in my mind, I would think it would be greater than or equal to, but it's really important to still test the point just in case. I've been using 0, 0 each and every time to do this, but I don't like to ever use a point that is on the line. So sometimes things can get tricky if the point you choose is on the line. So I'm not going to choose 0, 0. I'm going to choose a different point that is not on the line. I'm just going to use negative 1, 1. When I choose a different point that's not 0, 0, it's just going to change things a little bit because you have to do a little bit of math to determine if it's true or not. So I'm going to replace a negative 1 in for x and a 1 in for y. So when I do that, this says y blank 2 times negative 1 is negative 2. Now this region here that I chose my point is a part of the solution set, so I want this to be true. So the symbol that I'm going to choose here, either this one or this one, has to be true. 1 is bigger than negative 2. So from these two options, the one I would choose is this one right here. 1 is greater than or equal to negative 2, which means that the symbol I would need here is y is greater than or equal to 2x. So the method behind that is a little bit confusing, but you have to choose a point that's not on the line, test it to see what happens, and in this case we wanted it to be true since it's in the solution region. The only two options we have for the two to pick were these two because of the type of line. This one right here is the only one that makes sense because 1 is greater than or equal to negative 2. And then the very last one is actually probably the easiest because we don't need slope-intercept form since this is a vertical line. Vertical lines always start with x equals. So if this was an equation, this would be x equals, and I can see here that the point is 1, 0, crosses the x-axis at 1. So the equation would be x equals 1. Now because this is not just a line, this is an inequality with a shading to the left of it. Instead of it being an equal sign, I have to choose one of the 4 symbols. Since it's a solid line, it can only be less than or equal to or greater than or equal to. To determine which one it is out of these two, you look at the numbers that are shaded. And you only have to look at the x numbers. The numbers that are shaded are all of the x numbers to the left of it. So 0, negative 1, negative 2, and so on. What symbol would I need here then to show that it's all of the numbers to the left of it that are shaded?
Less than or equal to.
Yes, thank you. Less than or equal to. So that would be the answer to that last one there. Okay, and then the very last thing we're going to do is a word problem. So if we scroll down, well, if I scroll down to the last 2 problems here, We have 2 word problems that I know might not be your favorite thing, but here we go. Your budget requires you to earn at least $160 per week. You work 2 part-time jobs. One is tutoring, which pays $10 per hour. The other is at a fast food restaurant, which pays $8 per hour. It's saying let X represent the number of hours tutoring. I'm just going to write that down. X equals hours tutoring. And Y is the number of hours worked at the fast food restaurant. I'm just going to write Y equals hours at the food restaurant. A asks us to write an inequality that represents the number of hours you can work at each job in order to meet your budget requirements. So before we can graph anything, the first thing we should do is create the inequality in letter A. I know that we need to earn at least $160 per week. So if I'm tutoring or if I'm working at the restaurant, I know together I have to earn at least $160. So before I even create all of this stuff with the X and the Y, I know that at least 160 would be greater than or equal to $160. I know that because they say at least means greater than or equal to. And then on the left-hand side of this inequality, I need to put together all of the information I have. I know that I get paid $10 per hour to tutor. If X represents the number of hours that I tutor, and I get paid $10 per hour, I can use 10 and multiply that by X to represent how much money I get by tutoring. And if I add that to the amount of money I make while working at the restaurant, I know that I make $8 per hour at the restaurant, and Y represents the number of hours I'm at the restaurant, so I can multiply 8 times Y to represent how much money I would make at the restaurant. So the inequality that I have right now is 10x plus 8y is greater than or equal to 160. The 10x term represents how much I make while I'm tutoring times how many hours I'm tutoring plus how much I make while at the restaurant times how many hours I'm there. And altogether, that sum must be at least $160 total per week. So that's the inequality. But now, in order to graph this, I have to make this a little bit easier for myself. And I know that recently we've been doing a lot of these graphs by solving for y, and let's see how that goes if we do solve for y. So in order to graph this for letter B, I would take this inequality and I would solve it for y. Step 1, let's move the 10x to the other side. When I do that, I'm left with 8y is greater than or equal to negative 10x plus 160. And then I'm going to divide everything by 8. And I'm going to get y is greater than or equal to negative 10x over 8. I can simplify this by dividing both by 2 here. So it's going to be negative 5 over 4x plus 160 over 8 is 20. Now, the only issue with this right now is that the graph they give us is not big enough for this graph. So instead of using the numbers that they give us on this graph, why don't we just make everything 2 times bigger by making this a 10 and making this a 20 instead, and making this negative 10, negative 20. We can leave the other ones the way they are for now if we want. So the y-intercept that I have here is 20, so I know that if I was to graph this, I would need to graph 0, 20, so that since I renamed my graph, I can put the point there so that the y-intercept fits. And then to use my equation or my inequality to graph another one, my slope is representing down 5 to the right 4. Which is the same thing as down 10 to the right 8 from before. So it's important that when I'm doing down 5 to the right 4, I realize that these are going by different numbers right now. Like if I went down 5, 1, 2, 3, 4, 5, because I renamed these, I would actually be going down 10 and not 5 since I numbered them differently. Hopefully you see that. So if I was going down 5, I'd only be able to go down half of the way, not the whole way, because that would be down 10. And I have to make sure that I'm matching up with down to 5 over 4. So if this was if this was going from 10 to 20, in between right here would be actually down 5, right in the middle. And my graph's my calibration's still off, but going down 5 would be going down halfway, and then to the right 4, since I didn't change those numbers, would be over here to the right 4. Once you have 2 points, you can then make your line. Because it is a because it is a greater than or equal to symbol, it will be a solid line. So it would look like this. And this is an interesting problem because since this is a word problem, a lot of things will not make sense. So if I gave you this type of graph and I said, here you go, graph this, here's what you would have. And a lot of the numbers wouldn't make sense. Like if this graph kept going on forever and ever and ever, eventually you would get negative numbers down here. And if it went that way forever, you would have negative numbers to the left. And why do negative numbers not make sense for this problem?
You want to make money, not lose it.
You want to make money and not lose it. And look what X represents. X represents the number of hours that you tutor. Why would it not make sense to have negative numbers for X? Ava?
You can't go back in time.
Yeah, you can't go back in time and have negative hours tutoring. And same thing with hours working at the food restaurant. Y represents the hours you work at the food restaurant. You can't have negative hours. So this is not the type of graph I usually would give you for a problem like this. The type of graph I would usually give you looks like this. It's just the positive section of a graph. And for these types of problems, sometimes when you only have the first quadrant, you can just number things on your own. Like if I was just going by 5s, 5, 10, 15, 20, here's my y-intercept, which is 0, 20. And I like to also label these with the actual labels. So y is the hours at the food restaurant. X is the hours tutoring. And then when I have real world situations like this, it's honestly super helpful to find not just the y-intercept, but the x-intercept. So if you think back to what we did in the last section, and we look back at this original inequality, 10x plus 8y is greater than or equal to 160. Do you remember from chapter, I think it was either in the beginning of chapter 3 or in beginning of chapter 3, if I said find the x-intercept, you make the y go to 0, and you would solve the little equation. You would solve the little equation, 10x equals 160. Remember we were in equations. Pretend this was an equal sign and not an inequality. So 10x plus 8y equals 160. Do you remember when we would find the x-intercepts, we would let the middle one be 0, solve 10x equals 160, we would get x equals 16. That means that on here, your x-intercept would be at 16. And then once you have your x and y-intercepts, then you can connect your line, and that line makes a whole lot more sense because this line is representing all of the positive numbers that would work. The graph that's given for these problems doesn't really work because all of these negative numbers down here and negative numbers here won't actually make sense for this problem. So I don't like the graph that's actually given for this. A first quadrant graph would be a whole lot better. Then in letter B, after it says graph the inequality, it says identify 2 ordered pairs that represent the number of hours you can work at each job in order to meet your budget requirements. So in order to figure out what type of points you can use here, you could use any points that are on the line or any points that are going to be actually in the inequality. I still didn't finish the problem yet because we have to still shade the solutions. This symbol here says anything greater than or equal to. Because this is my line here, I can test 0, 0 if I want. And 0, if I test 0, 0, I'm going to get that this area down here is not true, which means all of the area above, so anything above the line, will actually be the solution. Which means any point above that line or exactly on that line will be a solution of this inequality, which will make me earn at least $160. So if you chose any point above this line, you're going to get an answer that's true. Like this number here is 16, and then up here is 20. So if I just chose like a random point, let's say I choose this point here, and say that this point is 18, 22. If I use that point here, that point will be a solution because it's in the solution region. And I could double check by taking 18 hours tutoring, multiply it by $10 per hour plus $8 per hour times $22 at the food restaurant. I'm going to get more than $160 total. So you can choose any point that's in the solution region, and those points will all work. You can also use any points that are on the line. 16, 0 will work, and 0, 20 will also work. If you don't work at the restaurant at all, but you work 16 hours tutoring, you'll still make $160 exactly, so that will work. And vice versa, if you don't tutor at all, but you work 20 hours at the restaurant, that will make you exactly $160, which will work as well. Okay, that was a lot, but does anyone have any questions? In order for you guys to really practice this, because on our next quiz we will have a problem like this, and this is tough stuff, I want you guys to try the next one, so the storage space example. It says a warehouse for storing desks and filing cabinets has 2,000 square feet of floor space. Each desk requires 15 square feet of floor space, and each filing cabinet requires 6 square feet. Write a linear inequality for the space constraint where x is the number of desks and y is the number of filing cabinets stored. So very similar to the first one in that they give you something for x, they give you something for y, and they give you a limit. The only thing about this one is it's not going to be exactly the same because this one you wanted to make at least $160 per week. This one, the limit is 2,000 square feet, which means you can't go over 2,000 square feet for the desks and the filing cabinets they're putting in. So they tell you what they want you to use for X and Y. Go ahead and try this. In a few minutes, I'll start going over the problem, and then we can sketch the graph together. Alright, so they tell us in the problem X is the number of desks and Y is the number of cabinets. I don't know what's up with this. They tell us the warehouse has at most 2,000 square feet. You have to kind of pull that out from the problem. It doesn't say the word at most, but you have to realize you can't exceed that. And each desk requires 15 square feet of floor space. Each cabinet requires 6 square feet. So if the desks require 15 square feet, this would be 15x. If this filing cabinets require 6 square feet, this would be 6y. The sum of these two square feet cannot exceed 2,000. So what symbol would I have to have here to show it can go over 2,000? Sophie? Yes, perfect. Less than or equal to. So that would be the inequality. And then to graph this, again, I don't like the graph that's here. I would prefer to have a first quadrant graph where x is the number of desks and y is the number of cabinets. And the easiest way to go about this is honestly not necessarily putting it in slope-intercept form, but just graphing the x and y intercepts. To find the x-intercept, you let y go to 0, and you would just solve the little inequality. 15x is less than or equal to 2,000. Solving this, just dividing by 15, it's going to tell you where to plot on the x-axis how many desks would be the limit here. So 2,000 divided by 15 is 133.3 repeating. That's the x-intercept. And then the y-intercept, you would let x be 0 and solve the little inequality. 6y is less than or equal to 2,000. You would divide by 6, and you're going to get y is less than or equal to 333.3 repeating. So that's weird because the numbers have decimals in them, but when you're going to graph these, you would just figure out what you would go by that would make sense. Just because of time, I'm just going to go by 50s. So 50, 100, 150, 200, 250. Probably could have went by hundreds. 300, and then 350. And I'll go by 50s down here too. You don't have to go by the same thing for each one. For the x-axis, I need to plot about where 133.3 repeating is. So it's going to be in between 100 and 150, a little bit closer to 150, so I'm going to put it here. And then for the y, it's going to be in between 300 and 350, a little bit closer to 350, so I'll put it here. This line will be another solid line because the less than or equal to. And then where will the solutions be? Will it be under the line or above the line?
Under.
Yes, this one will be under the line. And I could use 0, 0 to test that point. 0 for x, 0 for y. 0 is less than or equal to 2,000, so that means that underneath the line would be the solution region. Which also makes sense because when you think less than, you would think underneath it would be lower, and that's the way it does work. So this one doesn't say to answer how many points, like for specific points, but any point that's in this line, underneath this line, would be a solution, like 50-50. So you could have 50 desks and 50 cabinets in that space, and it would work. So I didn't have enough time to get to section 3.6, but that's okay. We'll just start with that tomorrow. And we'll just be quickly learning tomorrow, Wednesday, and Thursday to try and get everything in so we can review and have our quiz before we leave for Thanksgiving break, which is next Tuesday.